In this video, we'll talk about the average rate of change. Say we have a function f and a and b are two elements in the domain of the function f, and they're not equal to each other. Then the average rate of change of this function f from a to b is defined as f of b minus f of a over b minus a. And you can see from the top, that's the change in the y value. Because on top we have two y values, and at the bottom we have two x values. So that's the change in the x value. So we call that delta y over delta x. Say the graph of a function f look like this, and a is here, and b is here. So you can see, okay, well, then this value will be f of a, and this, the corresponding y value here will be f of b, right? And so this point will be a, f of a, and that point is b, f of b. Okay, so what is this average rate of change? Well, it's defined as, first of all, it's f of b minus f of a. What is f of b minus f of a? So basically it's this value minus this value, which is this distance, right? Okay, divided by, well, let me move it over here to make it more clear. It's this distance divided by b minus a. So what is b minus a? Well, it is this distance. Or let me write it over here. This distance, right? That's b minus a. Okay, again, that pink segment or pink distance is f of b minus f of a. So f of b minus f of a over b minus a, that's just rise over run, isn't it? So basically, the average rate of change from A to B is just the slope of the line passing through these 2 points. We call a line that intersects a curve with 2 points a secant line. And the average rate of change from A to B is just the slope of the secant line passing the point A, f of A, and B, f of B. Knowing what the definition of average rate of change is, let's do a problem related to it. So we're given a function h of x, and A, we want to find the average rate of change from 3 to 6. Okay, let's say this is the graph of the function h of x, and this point will be 3. Well, what is the y value? So we know the x value is 3, and the y value will be h of 3, right, which is 3 squared minus 4 times 3. That is 9 minus 12, which is negative 3. Okay, so 3, negative 3 is our first point. And that point, the other point, will be 6. That's the x value. The y value is h of 6, which is 6 squared minus 4 times 6, which is 36 minus 24, and that is a 12. Okay, so 6, 12 is the other point, right? So the average rate of change from 3 to 6 would be the secant line passing the 2 points we just got, which is the rise over run over here, right, between those 2 points. So that will be, okay, so first of all, the rise would be 12 minus negative 3. Right, so 12 minus negative 3, that's the rise part, over the run. So over the run part happens over here, which is 6 minus 3. Right? So to do the calculation, we have 15 on top divided by 3, and that is a 5. So the average rate of change from 3 to 6 is 5, which we know it is also the slope of that secant line. Well, this information will help us to solve the B part. Find the equation of the secant line containing 3, h of 3, and 6, h of 6. We already know the 2 points are 3, negative 3, and 6, 12, right? We just calculated what is h of 3 and what is h of 6. We want to find the equation of the secant line. So what do we know here? First of all, we know this line passed through 2 points, right? One is 3, negative 3. The other one is 6, 12. And also we calculated the slope of the line, which is 5. We know a lot here. So we know the slope, we know 2 points. So if we know the slope and 1 point, we can find the equation by using the point-slope form of a line, right? What is the point-slope form of a line? It is if we know the slope of the line and a point on the line, let's call it x1, y1, then the equation of the line will be y minus y1 equals m times x minus x1. Right, so here we know the m is 5, and we can use 6, 12, or if you want to use the other point 3, negative 3 as your x1, y1, both points are okay. So I'm going to use the 6, 12. So that will be my x1, y1. I'm going to plug in the information I have into this point-slope form. Okay, so y minus my y1 is 12 equals, my slope is 5, times x minus x1 is 6 here. Okay, all I have to do is simplify this form. So y minus 12 equals, distribute 5x minus 30, add 12 on both sides. So I have y equals 5x minus 18. And this equation will be the line, the secant line, the equation of the secant line that we're looking for. And that will be the end of this video, and I hope you find it helpful. And I will see you in the next video.